Good morning, everyone. So this project was done on the quantification of the effect of near-harvest temperatures on pitburn and heat damage in cold stored plums and the prediction method development. So obviously, just a quick introduction. With the global warming becoming more prominent, knowledge on management of pitburn and heat damage in plums will be critical to be more economically viable in the future. The symptoms of the exposure to heat waves is basically in two forms. You get pitburn, and that's a dark discoloration of the inner flesh around the stone, and that's normally visible at harvest already. And then we've got the internal browning, and that you can't see at harvest, and that's the discoloration of the mesocarp. So the aim of the research is to ascertain the impact of near-harvest temperatures on internal disorders in cold stored plums, and this test of the Letitia prediction model, and this work was done on Letitia. And so temperature loggers were installed to measure air and fruit pulp temperatures prior to anticipated heat waves. The experimental site selection was based on the likelihood of heat waves in that area and also on susceptible cultivars. And in this work, we did 4 orchards of Fortune and 4 orchards of Letitia. And we increased it this past season, but we don't have the data analyzed for this past season yet. So fruit pulp temperatures were measured on the east and the west side of the trees, so to see if there's any differences, and we also recorded the relative humidity in those orchards. So this is just an example of a Letitia orchard in the Bonneville area. This you can see is the east pulp temperature readings. And you'll see the difference now. There's your west side. So you can clearly see that the morning sun on the east side is warming the fruit up faster. And as soon as they are cooling down and the sun goes over, you'll see the west fruit also warming up on that orange peaks. So that you can clearly see the effect of the sun on the fruit temperatures. And then the blue light is the air temperature. So in some cases, you can actually see a quite big difference between your air temperature and your fruit pulp temperature. And in some cases, it can be as high as 10 degrees higher than the air temperature. And then we also measured the relative humidity. So you can see as the temperature goes up, your humidity decreases. And that's normal for any model. So on the left side there, you can see Fortune plums exhibiting internal browning after storage. And on the left, you can see example of the pitburn that's between halfway between the stone and the outer and the skin, and then also with some internal browning also visible. So just a few conclusions that I made. Fruit pulp temperature reaches up to 10 degrees higher than the air temperature at the hottest time of the day. In most orchards, the pulp temperature on the fruit on the east side were higher or similar to the west side, except for an orchard located in Wolseley. Fruit pulp temperature, Fortune plums were more susceptible to pitburn, and this may be due to the timing of the heat wave just before the harvest. It is postulated that the short time between the heat wave and the harvest resulted in adequate preconditioning of the fruit and the tree to the heat wave and the stress that goes along with that. We also tested some of the orchards were under shade net, and there we saw that the orchards exhibited temperatures higher than open orchards, but direct sunlight, external heat damage to the fruit was reduced, as seen in both orchards that was with net on Fortunes and Letitia's. So once more data is generated over the 3 years of the project, the aim is to develop a pitburn heat damage prediction model that can be used by growers and packers to assess fruit quality risk in plums, and that was subjected obviously to the higher temperature, and you can then decide on which market you're going to target, because we know a longer storage will worsen the internal browning that you will get from the heat damage. And yes, you can make better decisions for the economic importance for your business. Thank you very much. Just want to thank Ward Crow also for the funding.